Hello everyone and welcome back to Zero IT. In today's episode, we will learn about ARP table, MAC address table, and also how switch treats packets. So let's begin. The first thing to do is to check the ARP table for the PC1. So we need to use the command ARP-A. As we can see here, we don't have any ARP entries for this table. Now, we need to check the MAC address table of switch 1. So the command is show MAC address table. We see here that there is no entry for this MAC address table. Next is to try to send a pin from PC1 to PC2. So the IP is the 12. Now, how many envelopes we have here? So we have two. We have one for ARP, another for ICMP. Now, why? Let's explain. I will say before, we didn't have any entry for ARP. That means that this computer doesn't know anybody. Yes, it doesn't know. So in order to know the owner of this IP, he needs to send an ARP packets in order to find, right, or locate and know the owner of this IP. So what type of address he's gonna use to find out? So he's gonna use a broadcast physical address. So this means that he's asking everybody, right, everybody out to whom this IP belongs to. There is not a specific target because he doesn't know it, right? So this is the physical address of hosts, and this is a broadcast. It's intended for everybody. So now, as we see, what does happen when switch 1 receives this packet? So he de-encapsulate, right, these packets, and he's only able to check the layer 2 information, layer 1 and layer 2. At layer 2, he said that it is a broadcast, right? That means that he needs to float all its ports. But before forwarding and doing so, he is gonna save the physical address of this host on the port 02. So now we can see on the MAC address table that this host is located on the F02. And when somebody is intended to send any packets to this host, the switch will know where to send it, the port 02. After learning so, it's gonna flood the port, right, because it was a broadcast. Now PC3, when it's decapsulate the packets, for the layer 2 is intended for everybody, so that's why he received it. Now on the layer 3, he see that the destination is the .12 and it is .10, so it's not intended for it, so he discard the packets and there is no answer. But the PC2, when it's encapsulate, he said, okay, that's for me, I am the 12. Now he's gonna respond back, right? And the response has the physical address, right, or the PC2, right, the responder, and also with the necessary information. Now he's gonna respond back when the switch received these packets before sending out. As he doesn't have any entry for that host, he first save and learn this physical address to the MAC address table, right? And it gets associated to a port and then send it back to PC1. He saw the destination was the physical address of PC1 that he already knew. Now the PC1 knows to whom that IP belongs to. Now he's gonna send a unicast, right? He's gonna send a unicast. As we can see here, there is and a specification to whom this ICMP is intended for. This is the physical address of PC2. So the switch, as already has the entry for the PC2, he knows where to send it. So he send it out for port 3, PC2 receive it, and then send them back to PC1 as the response of the ICMP. So this is how the ARP tables and MAC address tables work, and also how switch 3 packets when coming in and sending it out.